Okay, so in this example, we're going to solve the trig equation cosine of x divided by cotangent of x plus 2 sine squared x equals 0 for all angles in the interval 0 to 2 pi inclusive. Since it's 2 pi in our interval, we know we're going to be working in radians as opposed to degrees and 1 lap around the unit circle. So first thing we want to do when we have a trig function, three different trig functions in the same equation, is try to get it all in terms of the same trig function. So let's tackle this quotient that we see at the beginning and see if that's a quotient identity from our trig identity hexagon. So here's cosine in the numerator and cotangent in the denominator, and if you recall, two consecutive vertices do make a quotient of the one ahead of it. So the sine is equal to the cosine divided by the cotangent. So that means we can replace cosine divided by cotangent with the sine. I think my marker's about to die here. We'll switch colors. So let's try blue instead. So that will be the sine of x plus 2 sine squared x is equal to 0. Now we can see that there's a sine of x in the first term of this binomial, and there's also sine of x in the second term of the binomial. So we can pull that out to the front, factor it as a GCF. So we'll have sine of x now times the quantity 1 plus 2 sine of x equals 0. And now that it's completely factored, it's equal to 0, we can use the zero product property to solve this by setting the first factor equal to 0, sine of x equals 0, and then setting the second factor, 1 plus 2 sine of x, also equal to 0, and solving those two equations separately. So here in sine of x equals 0, we take the inverse of both sides, and x is equal to the arc sine of 0. And that's asking us the question, what angle on the unit circle has a y-coordinate of 0? So if we sketch a quick picture of our quadrantal angles, this is 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi. And the center of the unit circle is the origin, 0, 0, and the radius is 1. So if we go from 0, 0 to 1 in any direction, we're going to get these coordinates 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So we're looking for the angles where 0 is the y value, and that's going to occur here at 0 radians, 2 pi radians, and at pi radians. So those will be the three solutions: x equals 0, x equals pi, and x equals 2 pi. Okay, now we're going to do the same thing and solve the other equation here on this side. And let's go ahead and make some room for that. So over here, we're going to subtract 1 from both sides, and 2 sine x equals negative 1. We'll divide through by 2, and sine of x is equal to negative 1/2. And then to get the x by itself, we'll take the inverse sine of both sides, and x then is equal to the arc sine of negative 1/2. So that's asking us on the circle to first find the reference angle. So that would be the first quadrant angle that has a y value of 1/2, and then to reflect that into the quadrants where sine is negative. So in quadrant 1, those of you that have a unit circle handy, you can go ahead and just look for it in quadrant 1. Everybody else, this is 0, pi over 6, pi over 4, pi over 3, and pi over 2 from the first quadrant. And our coordinates here are 1, 0, and then root 3 over 2, comma 1/2, root 2 over 2, root 2 over 2, 1/2, root 3 over 2, and then 0, 1. So that's our first quadrant, and we can see that the sign, the y value here at pi over 6 is 1/2. So pi over 6 is going to be the reference angle from quadrant 1. That reference angle is not one of the solutions, right? It can't be a solution because sine is positive in quadrant 1, but it's the reference that we're going to use to find the solutions. So if you remember that acronym, all students take calculus. The A stands for all the trig functions being positive in quadrant 1. S means sine and its reciprocal are positive in quadrant 2, so there will not be a solution for us in quadrant 2. The T is tangent and its reciprocal are positive in quadrant 3, and then C, cosine, and its reciprocal positive in quadrant 4. So we're going to look for answers in quadrants 3 and 4 because that's where sine is negative. So we'll reflect this reference angle into quadrant 3 and into quadrant 4. So if halfway around the circle is 6 pi over 6, then one more down into the third quadrant would be 7 pi over 6. If the whole way around the circle is 12 pi over 6, because that's 2 pi, then going back clockwise, we subtract and we get to 11 pi over 6. And so those are the two solutions to this equation, x equals arcsine of negative 1/2. So x is equal to 7 pi over 6, and x is equal to 11 pi over 6. So that's 1, 2, 3, 4, 5 solutions that we want to check for this equation. So if you've been following along with the earlier videos, most of these we've been checking on the graphing calculator. Just to mix it up a little bit, we're going to go ahead and check this one on the graph using Desmos. So let's switch over here. See if I can get that in the bottom corner there. I think so. Yeah, there we go. Okay, so now in Desmos, in the y equals, I put f of x equals cosine of x divided by cotangent of x plus 2 sine squared x. That's our original equation. And when you click on the graph in Desmos, see these little gray dots? They get highlighted here automatically. These are all the critical points, so your maximums, your minimums, and the zeros. And as you click through, you can see here are our answers, right? There's 0, there's pi, there's 7 pi over 6, there is 11 pi over 6, and there's 2 pi from our points where this equation is crossing the axis. Okay, another way you can look for these zeros in Desmos is if you click on the equation itself and then come up to, let's see if I can move this up, then you'll come up here to this gear icon, and next to your equation there's a little table. If you click on convert to table, now in this X box here we can change this to 0 and get the y, the f of x value that goes with it. So if we want to check what happens at pi, we type pi and we have a 0. If we put in 7 pi over 6 and press enter, now this one gives us scientific notation, negative 3.885781 times 10 to the negative 16. That's 16 zeros in front of that negative 3, so that's really close to 0. If we put in 11 pi over 6 right? Same thing. We get really close to 0. And then 2 pi was our last answer, and that one comes up as equal to 0. Now, another way that you can check them is instead of putting your whole equation in here, you can do half of it at a time. So if we take this half here, but we'll have to change it to g of x since we already have an f of x. So that's the graph of cosine of x divided by cotangent of x, which remember is sine. So if you look at the graph, you can see there's our sine curve bouncing back and forth from -1 to 1, you know, starting at 0 with its zeros at pi, 2 pi, 3 pi, just like we expect. And then in the next graph, we'll do the other side of the equation. H of x equals, and that would be a -2 sine squared of x. Because if I started here, and I don't know if you can see in my, maybe I can move this back up again, but where we started, we had cosine of x divided by cotangent of x plus 2 sine squared x equals 0. So to move that 2 sine squared x over to the other side, we have to subtract it. So now we'll press enter, and the solutions to this are going to be wherever there are points of intersection between these two graphs. So I'm going to see if I can get that out of the way. There we go. So I'm going to click on either of these curves, and let's actually change their colors here real quick so that we can tell which are which. So we'll make that one red and this one blue. There we go. So when I click on the g of x, the red graph, notice again it highlights all these critical points for each, but in particular I want to pay close attention to these points of intersection. So here are the 5 points of intersection between the left side of the equation and the right side of the equation. And there they are at 0, 7 pi over 6, pi, 11 pi over 6, and 2 pi. So those are also the same solutions that we had when we solved it out algebraically. So this is just another way you can check instead of using the graphing calculator. Okay, I hope that helps.